Hello, Year 11s. This lesson is going to be on completing the square, which involves taking a quadratic function from standard form into turning point form or vertex form. So with quadratic functions, a lot of the time we want to be able to easily identify what the turning point is. So to have a quadratic function in this form here is extremely useful because it means we can easily identify what the x and y values of the turning point are. So why is this important? So if we have a if we had a quadratic function represent a real life scenario about, for example, a company and how much profit it makes based on how many units of a particular product it sells, the quadratic uh, function might look something like this. And we'd be interested in finding what X value or how many products should the company sell in order to maximize its profits. Okay, so that's just one example of why we'd want to find a the turning point of a quadratic function. Okay, so let's look at a few examples on how to actually complete the square so we can get a quadratic function into turning point form. So if we have a look at example A here, so we've got y equals x squared plus 6x take 3. So what we do is we write down the equation y equals x squared plus 6x, and we leave a bit of a gap in between the next term, which is negative 3, and you'll see why that is in a second. And as the formula here says, all we're going to do is we're going to grab the coefficient of x, we'll halve it, and then we will square it and add it on. Okay, so 6 divided by 2 would be 3, and then 3 squared is 9. So I'm going to add on 9, but obviously I can't just add on 9. I have to make the equation balance still, and so what I do is I take 9 as well. So I haven't actually changed anything. And so what you might notice here is that I can now factorize this, what I've just underlined. So this factorizes to x plus 3 squared, okay? Because if I think of two numbers that add to 6 and multiply to positive 9, then it's 3 and 3. And then at the end, I've still got this minus 9 take 3, which is minus 12. So now my function is in turning point form. And what I've done is I've completed the square. I've made this part here into a square. You can think of it as being a square with side lengths x plus 3. So now that I have it in turning point form, I can clearly read off what the turning point is. So the turning point is minus 3 minus 12. And the nature of the turning point would be a minimum turning point. A minimum turning point. And we know that because the value of the A value is greater than, or it's equal to 1 in this case. So it's positive. All right, so we know that's 1. We know it's a minimum turning point. If it was like -1 or -2, it would be a maximum turning point. Okay, now why does this actually work? So, so this isn't just made up. Let's think about why visually completing the square and doing this thing where you go 6 divided by 2 and square it. Why will it actually give you a function in turning point form? So if we just focus our attention to x squared plus 6x, and we won't worry about that minus 3 that we had before for now. So when if you were to represent this visually, you can think of x squared as being a square that literally has sides x and x. So I've got x here, Now, 6x visually, you could think of it as being 6 this x this way, and then 6 long. So when you first divide this coefficient by 2, what you're actually doing is you're splitting this rectangle into two pieces. So you're splitting it here so that instead of it being 6 long, you can think of it as being 3 and 3. And now, if I just grab this top piece and if I rotate it, say at 90 degrees, and put those three pieces together, look at what happens. So I have my x and x, that doesn't change. And like I said, if I were to grab this piece here, and I would just rotate it, then I would have so that would be 3 and this would be x. And then the other piece, this piece here, I'm just going to draw here. I'm going to keep it in the same orientation. And so this is 3 and x. You see that this is almost a square, but it's missing this last piece. So in order to make this expression, in order to make this x squared plus 6x a square, I have to do what? Well, I have to add on 9. And where do I get 9 from? Well, I get 9 from doing 3 multiplied by 3. So 3 by 3 gives me 9, which is this part here. And so you can see visually that you're literally completing the square. You're making something that didn't used to be a square into a square. Okay, so dividing by 2 allowed me to split this. So when I divided the 6 by 2, it allowed me to split this piece into 2. And then I was able to rotate that around and show you guys how I actually complete the square. That's pretty cool. Okay, now let's have a look at example B. How would we complete the square there? Make it into turning point form. So if I've got y equals 2x squared minus 4x plus 1, and I told you at the start here that completing the square only works when a equals 1. So if I've got a equals 2 here, I'm going to factorize the first two terms here so that I get it just where a is equal to 1. So if I pull out here a common factor of 2, then this would become then what I've got is 2x squared take 2x plus 1. And so I'm going to be completing the square here. So equals 2 lots of x squared take 2x. And remember, to complete the square, we grab this term with this number here, minus 2, divide that by 2 and square it. So minus 2 divided by 2 is minus 1, and then minus 1 squared would give me just 1. I'm going to add 1, and then I'm going to also take 1 to keep it balanced. So I can now produce a square out of this part here. So I've got 2 lots of, if I were to factorize this, I've got x take 1 squared, and I've still got this take 1 plus 1. So now, what do I have? Okay, so I know I've got, if I expand the brackets here, if I multiply that by 2 by everything inside the bracket, 2 x take 1 squared, take 2, because 2 times minus 1 is minus 2, plus 1. And now if I simplify this just by collecting the like terms, the constants here, I've got 2x take 1 . So that was 2x take 1 squared minus 1. So now I know that the turning point is just 1, so opposite of what's in this bracket, 1 and then comma minus 1. And I know that, again, this is a minimum turning point because the a value was 2. So that's how we complete the square to transform a quadratic function from standard form into vertex form. So just remember, you always, before you complete the square, you have to have the a value be 1. And if it's not 1, then you need to do something. You need to factorize to make it 1. So if you do get to a question where you've got like y equals negative x squared, just making this up, plus 6x plus 13, for example, you would just have to you would have to factor out a negative 1 first. So you could go negative x squared, take 6x, and then you could have plus, take 13. Okay, and then you do completing the square on this bit here and just have the negative sitting on the outside. All right, I hope that helps.